All right, welcome back. This is our first section of our acids 2, acids, bases, and salts. So this one's called hydrolysis. So basically hydrolysis, this is when so if you break up the word hydrolysis, so hydrolysis, so it's water is going to break up something. So basically what we're going to do, we're going to throw salt into water. It's going to break up by the water, and we're going to decide whether it's going to act as a acid in solution, a base in solution, or it will be neutral. So a little bit of a review. So acid base. So how do salts form? You got acid base, and then you're going to make your salt in the water. The salt is made up of a cation and an anion. Cation positively charged, anion negatively charged. Sometimes ions form the salt, and the salt may react with water as acids or bases, and that's what we care about, whether it's going to be acidic solution or a basic solution. So our definition of hydrolysis, this is the reaction between water and the cation or anion or both. And then we might have to do a little bit of calculations of the salt to produce an acidic or basic solution. All right, so first of all, let's talk about spectator ions because then it eliminates stuff. Because with spectator ions, we don't have to worry about them at all. They're just going to it's just going to be neutral. They're not going to react with water. They're not going to produce acidic solution. They're not going to produce a basic solution. They're just going to float around in solution and not do anything. So I think, so to visualize this a little bit, so we have NaCl, add AgNO3, and we're going to form the precipitate, AgCl, right? So these Cl minus ions over here, they're going to react with the Ag plus ions. They're going to form this precipitate at the bottom. And the NaNO3, these are going to be the spectators. They're just going to be floating around. In chapter 3, we talked about net ionic equations. So the net for this would be Ag plus and Cl minus goes to AgCl, right? This is the reaction that we care about. Aqueous ions producing a solid precipitate. So we care about those ones. These are the ones that are reacting. The spectator ions, they're just floating around, not doing anything. So again, do not hydrolyze. They're the conjugates of the strong acids and bases. All right. So to connect this with your table, so take out your table, and we're going to look at these top 5 here. All right. So these are all the conjugates of our strong acids, right? So they're not going to react as bases at all. So these are the anions. They do not hydrolyze. And notice the one-way arrow, no equilibrium being formed. They're not going to react with water. So anytime we see these top 5, all we have to do is just ignore them as spectator ions. All right, so they're not going to change the pH of the solution. Well, why not this guy here? So this one's it's the conjugate of a strong acid. So why isn't this one going to why isn't this one going to be a spectator ion as well? Well, it's because we see it on the other side, right? The HSO4 minus, right? So we see it over here. It's going to be it's going to act as an acid, right? So it's not just going to be a spectator floating around. The first step, it's going to lose that H plus. It's not going to go back and gain that H plus. There's no equilibrium. But the second one is going to act as an acid. All right. So it's lower down on the left. It is amphiprotic, and we've talked about those before. So our spectator cations, these top 5, all we have to know is how to recognize them on the table and know that they're not going to influence the reaction at all. They're just going to float around in solution. All right, our anions, which do hydrolyze. So anions are negative charge ones. So basically everything from your below your SO4, all those anions, all those negative ions, all the way down, they are all going to act as bases. All right, so in solution. So if we see these guys, if we see any of these anions in the solution, we're going to assume that they're bases. It's going to act as a base. Unless it's on both sides, then we have to make a little calculation to decide which hydrolysis dominates. Okay, so our spectator cations, very easy. These are our conjugates of our strong bases. So the group 1 and group 2, alkali metals and alkaline earth metals. They do not hydrolyze, they do not react with water, so they're just going to be spectators. All right, so column 1, column 2. So make a note of those guys in your for your notes. All right, so all the cations, we don't have to worry about them. Other cations which hydrolyze, 3 common on the left. So the first cation pretty easy to talk about. So that's just our ammonium ion, NH4 plus, reacts with water, make H3O plus, and your NH3. So NH4 plus, that's fine. Fe3 plus, we can see it right there. So Fe3 plus, third from the top, and our Cr, all right, Cr3 plus, and the Al3 plus. All right, so we look at these guys, we're like, well, that's not Fe3 plus, that's FeH2O6 3 plus. That's a hexa aqua iron ion or iron 3 ion, right? So, but with this one, any Fe3 plus is going to react with water, right? According to this reaction here, every Fe3 plus reacts with water and produces this weak acid. Then it will go on, react with more water, and it will build this equilibrium here. And we see this equilibrium on our table, right? So water is not included in that. So it's going to make that equilibrium. So any Fe3 plus, it's going to hydrolyze, it's going to react with water to form a weak acid. That's what we need to know. Same with Cr3 plus and Al3 plus. All right, so don't get fooled with these guys. You don't have to know these mechanisms or anything like this. You just have to be able to read the table and note that this one's going to act as an acid. Fe3 plus will act as an acid in solution and form the equilibrium there. Same with Cr3 plus and Al3 plus. All right, so this is types of questions that you'll get. So how to determine whether the salt is acidic, basic, or neutral. So the first step is to write out the dissociation of the salt, determine the cation and anion. All right, so we've been doing this all along since grade 11 and 12. So we're going to keep on doing this. So just break it up into cations and anions. Eliminate the spectators. So our conjugate acids, so the conjugates for the base, just get rid of them. We don't worry about them at all. We'll just label them as spectators. All right, then we have to locate the remaining ions on the acid table and decide whether they undergo base hydrolysis or acid hydrolysis. So for example, if we have NH4 plus, this is going to go under acid hydrolysis because we're producing H3O plus. We produce H3O plus, goes under acid hydrolysis. So it's going to produce an acid in solution, right? This H3O plus being produced is going to disrupt the Kw equilibrium and make it more of an acid. All right, same with a CO3 2 minus. This is going to produce OH minus, so it's going to act as a base in it's going to act as a base if we put it in water. All right, so if it's an acid only, it acts as an acid. Base only, it acts as a base. If it's amphiprotic, right, it's on both sides of the table. That means both ions hydrolyze. So we have to decide what is bigger, the Ka or the Kb. Ka is greater than Kb, it's acidic. Ka is less than Kb, it's basic. All right, so let's do some problems like what you'll see. So let's look at the first one. All right, Na, right? So that's in our first column of our periodic table. All right, so it's going to break up in the NaCl. All right, so that's your first step. Break it up. Na plus, right? That's in the first column of the periodic table. It's an alkali metal. It's going to be a spectator. Cl minus, obviously a conjugate of our HCl, so it's a spectator. So it's a neutral solution, and we could say NaCl is a neutral salt. All right, so no hydrolysis is happening here, so we don't have to worry about it. All right, let's look at B. Right, so this is going to break up Na plus and our acetate, CH3CO minus. Okay, Na plus, we know spectator. CH3CO minus, this is going to act as a weak base. All right, so you know it's going to be a basic solution because it's acting as a weak base. So what we need to do now, so maybe in a multiple choice question, we would just stop here. All right, so it's going to be a base in solution, and then you're done. But you might have some questions and it might ask to write out the hydrolysis reaction. So we just do it like we'd see it on the table. So CH3CO minus H2O, it's going to go to our acetic acid, CH3COH, and your OH minus, producing that hydroxide. All right, so that's the hydrolysis reaction. Again, we know it's acting as a base in solution because we're producing OH minus, and that's all we're producing. All right, next one. So we look at this one, break it up into ions, NH4 plus, Cl minus, right? Spectator. NH4 plus, going to act as a weak acid. All right, so that's the only way it's going to act. So it's going to be acidic solution and our hydrolysis reaction, NH4 plus, H2O, NH3, and H3O plus. So just like we would see it on the table, and add the water. That's our hydrolysis reaction. Again, producing H3O plus, so it's going to be an acidic solution. All right, so let's look at this FeCl3. Okay, so Fe3 plus and 3Cl minus. And you're like, oh, wait, I don't see Fe3 plus, but you're going to remember to when I talked about it before that Fe3 plus, we see if it breaks up in solution, it's going to react with water and it's going to form a weak acid solution, right? Cl minus, of course, spectator, only this acting, so it's going to be acidic solution, and our hydrolysis reaction will be just like we see it on our table and we write it out. All right, so weak acid solution, we're producing H3O plus, and we're good to go. All right, so now let's look at this one. So break it up, NH4 plus, CO3 minus. Oh, wait, NH4 plus is on the left side. This is a weak acid. CO3 2 minus, it's on the right side. It's going to be a weak base. So what's going to happen here? How do we know who's going to win? So we have to go look at our acid table and decide which wins out. So I'm going to write out so we have what we call here a double hydrolysis. So one's producing H3O plus, one's producing OH minus. So now we have to figure out who's going to win. So NH4 plus, we need to get the Ka. Ka, super simple. Just look at it on your table, 5.6 times 10 to negative 10. Our Kb, it's a little bit more difficult, right? So now we have to do our Kw divided by the Ka of our HCO3, right? So if we look on the table, Kw 1.0 times 10 to negative 14, and our HCO3, the K 5.6 times 10 to the negative 10. Oh, sorry, 5.6 times 10 to the negative 11. All right, so we do that, 6.8 times 10 to negative 4, and we can see this Kb is larger than the Ka, so the solution is basic. All right, last one, K plus, HCO3 minus, K plus, first column of the periodic table, spectator. Our next one, HCO3. Uh-oh, this one's amphiprotic. So now we have another double hydrolysis that's happening. So we have the acting as an acid, producing H plus here, and it's acting as a base. So now we have to do it again, find out which one is going to win out. Are we going to have an acid hydrolysis? Is it going to be acidic solution is going to win, or is it our basic hydrolysis, the base is going to win? So it's the same as before, Ka versus Kb. So Ka, very simple. Look at the table, and we see it is 5.6 times 10 to negative 11. All right, right there. Kb. All right. So remember Kw divided by the Ka of our H2CO3. A lot of students want to put Kw divided by 5.6 times 10 to negative 11, the Ka of our HCO3. All right, don't make that mistake because this is our acid, right? H2CO3 is our acid, HCl3 minus is our base. All right, so it's going to be a little bit different. All right, so it's going to be 1.4 times 10 to negative 14. Oh, sorry, 1.0 times 10 to negative 14. That's our Kw, and our Ka 4.3 times 10 to negative 11. All right, so we can see our base is our Ka is greater than our Kb, so it is going to be a basic solution. All right, so Kb is greater than Ka, so it's going to be a basic solution. All right, that's it for your first section. Do some of the problems from your assignment booklet, and you should be good.